Good morning and good afternoon, everyone. I'm Chris Spinagle from the Warning Decision Training Division. Along with me is Jill Hardy, also from WDTD. I'd like to welcome you to our fourth installment of our Revival of the Storm of the Month series. Today's presentation comes to you from the National Weather Service Forecast Office in Sioux Falls, South Dakota, and our presenters are Kyle Weisser and Phil Schumacher, who will be presenting an examination of the rapid evolution of QLCS tornadoes in Sioux Falls, South Dakota. And with all that being said, Kyle, the floor is yours, so take it away.
All right, thank you very much, Chris. Phil and I will be looking over at least to us, a fairly unique QLCS case that we had last September. It was a case that followed a previous QLCS case in August that kind of set the stage for how we were going to handle this case. We weren't planning on really making changes till the next severe weather season, but now that our severe weather season appears to be August and September instead of May and June, we had to enact this plan a little more quickly than expected. So on this night, we had 4 tornadoes. One was with a supercell that you can see on this loop merged with the line shortly before it really started to bow out. The other 3 were QLCS tornadoes that occurred in southern parts of Sioux Falls. What made this fairly unique was what appeared to be an interaction with some strong southerly flow on the line that was ahead of the bowing segment that did cause a pretty rapid change in direction of the mesovortices that were moving pretty much consistently all night from due west to due east with just a touch of a northward tick. And as they moved towards Sioux Falls, you'll see the motion was quite drastically different. What really makes this unique and helped us in this case, and Phil will hit on this, is a different staffing strategy to deal with QLCS mesovortices and splitting up operations and radar operations to deal with that. We'll take a quick look at the environment. We had a fairly strong jet maxima to the north with the right entrance region leaving the area, and then a strong trough out to the west digging in. It appears that both of these did help play a role in setting the stage for what was going on. You can see some influence of that exiting jet with some drier, cooler air moving in from the north. And then, of course, the digging trough across the west was allowing some strong southerly flow to develop in the central plains. And in the end, that left a very sharp boundary at 850 millibars right down Interstate 90 basically through South Dakota into Minnesota. And to kind of see just how steep that boundary was, as you get down to the surface, you can see the front was just about, at least as you get into far eastern South Dakota and Minnesota, was almost co-located with the 850 front. So they're very steep boundary there. So as the storms developed initially in north central Nebraska, south central South Dakota, they were probably just a touch elevated. But as they moved east through the evening, as we'll see, this boundary actually remained in place or even drifted slightly north as we got towards midnight. Here's a look at the Sioux Falls sounding, model sounding. This was the closest we could get to a 4Z is roughly when the tornadoes occurred. This is as close as we can get to the time of the tornadoes before all the models kind of started getting convectively polluted. But you can see, really in the low levels, the boundary, we were north of the boundary, easterly flow. There was some stronger flow aloft. You can see in the red box, we'll be hitting at what the importance of this, but you can see some fairly weak flow in the mid-levels from 800 millibars to about 500 millibars. And just to kind of show how the low levels were progressing through the evening, this is the significant tornado parameter. Parts of eastern South Dakota you can see actually increased through the night. At 0Z, we're sitting at a half or 1 on the significant tornado parameter, and by 11 o'clock or 4Z, it had to climb to 4 or 5. So we did see some increased shear and increased instability in the low levels. All right, on to some radar data. I'll kind of point out some differences. We had a number of small mesovortices, a couple of them more significant than the others. The main one we're going to be focusing on here is number 3. That's the one that's moving due east and will, in about 30 minutes, turn to the north and move into Sioux Falls. We'll have a little mesovortice track to help keep track of that movement. The enhanced southerly flow, that's something we're going to be looking at that may have played a role, or it definitely appears to have played a significant role in the track of this mesovortice. And that kind of occurred along and behind of this main area of convection out ahead of the main bowing segment. We are looking at a ½ degree in the top 2 panels for reflectivity and base velocity, and below it is 10 degrees. There's really no reason we picked 10 degrees. As you all know, when the activity gets very close to the radar, it's tough to keep a fairly consistent level. So even in this case at 10 degrees, you're talking about heights at about 5,000 to 7,000 feet in this area, and just 20 miles south, it climbs to about 18,000 feet. So we're really taking a steep cut through this. So we'll do the best we can to kind of indicate what was going on in the mid-levels with this enhanced southerly flow. So as we step forward, you'll see the mesovortices making a fairly nice progression eastward with the bowing segment. And you can see this little mesovortice wasn't doing a whole lot. This one was maintaining some fairly good strength. This one also looked pretty good. This little segment up here wasn't doing much, so we'll be focusing on these two, and especially this mesovortice. And you can see as we walk through time, there is some enhanced southerly flow, some downbursts, microbursts that are lifting northward and merging into this mesovortice as it moves east. And you can see there's really not much of a change. There's a few little mergers, maybe you could say here. Here's an initial one, and it doesn't really change too much. It maybe drifts a little bit north as that merges. But as we move in time, as it gets closer to Interstate 29, there's a little bit more of a larger enhancement coming out of this. And you can see these are right around 60 knots, I believe, on both. And right here is where they merge. So if you back up, you can see the merger. And just as they merge, you'll notice on the next step, we enhance the flow out of the south to about 80 or 90 knots. So it makes a fairly distinct change, not only in direction, but also in strength. And as that happens, you can see a small, very, very small little circulation here. Here's the larger circulation and microbursts drifting northward. Here's the next circulation that develops as it drifts north, and then our third circulation, the stronger of the three, that develops over south central Sioux Falls, right near the main shopping district. And really, to put it in perspective, sometimes I have trouble grasping this, working with the radar over the last 25 years. I'm used to seeing these every 5 minutes, so you think each scan's every 5 minutes, but really that quick turn only took about 3 to 4 minutes. So radar operators, we were fairly confident it was just going to stay on the very far south side of Sioux Falls, which T and Harrisburg are kind of the extreme southern extent of Sioux Falls. But just as it got past T, it took that very quick jog north. Again, as these southerly flow appeared to enhance this mesovortice and lift it northward. All right, we'll zoom in a little bit, and this is basically just zoomed into Sioux Falls. We have Interstate 90 to the north, Interstate 29 here, and Interstate 229, which loops around the east side of Sioux Falls. So we did have three separate distinct locations of enhanced damage that occurred. One was near the Heart Hospital in southern Sioux Falls. Another was through a couple of neighborhoods in South Sioux Falls, roughly from about 85th Street down to 57th Street. And then we had the larger circulation that occurred in the shopping districts right around 41st Street in South Sioux Falls. So as we move forward in time, this is about 45 seconds. You can see these two areas that the circulation enhanced. Very small. This is likely something. It's at 400. We're about 470 feet here at the yellow dot. These are probably running 700 to 900 feet. So these are things that you're probably not going to see very often. They're generally we're shooting over the top of activity like this. If we walk up a little bit, you really don't see that aloft. This is stepping forward another 45 seconds or so, and you can see this circulation starting to collapse a little bit. This one is still holding fairly strong. And as this occurs, we start seeing a little bit of a change up in here. So we'll back up a little bit. And as that occurs, this starts to wrap up. This strong southerly flow starts to wrap up. And here we've shot up to about 900 feet. Now we're a little bit higher. We're still shooting only, this is the difference here to here is only about 1 minute. So we've gone from some fairly weak to moderate convergence to our first hints that maybe there's some rotation. And again, you're only seeing this in the low level or at these cuts every 5 minutes. So this is something that if you're not seeing right away, you're not going to see anything else for another 5 minutes. As we walk forward about 30 seconds and up about another 400 feet, you can start to see this circulation. Now here's our drastic change. This is back down to our half-degree cut, so that's why we've got a little jump. We've gone from 1,200 feet down back to about 250 feet. And here, just 2 minutes later now, near the surface at 250 feet, we've got a very distinct, strong circulation that at this time was probably producing the tornado in south central Sioux Falls. So you back up 2 minutes before, this was what a half degree looked like. 2 minutes forward, the half degree at the same height is now showing a very strong circulation. And as we walk up in height, here's 1,500 feet, 2,000 feet, 2,500 feet, 3,000 feet. So you can see there was a very deep, strong, very quick developing circulation. 5 minutes later, this thing was fairly sheared apart and didn't last very long. So overall, this very strong circulation developed and probably lasted no more than about 5 minutes. And to kind of finish off what we were dealing with, again, this turn north took about 3 or 4 minutes. The image on the left is the base velocity at 425Z, and 2 minutes later at 427Z, we were dealing with a fairly strong circulation. And you know, a big shout out to everybody that's been doing QLCS research over the past several years. That's really helped us come to a better understanding of the environments, and it's also helped us think more about staffing and dealing with these environments. And Phil is going to be talking about how we decided to deal with this environment based off of that research and based off of some of the research that we did on a case in August. So I will pass this off to Phil.
Thanks, Kyle, and thanks everyone for listening. As Kyle mentioned, to really talk about our staffing model or what we use for staffing, we have to go back 3.5 weeks to August 17th in 2019. So this is 3 weeks before, and we had a squall line that moved across the entire forecast area from south central South Dakota through the southeastern South Dakota and into southwestern Minnesota and northwestern Iowa. And so these are the reports that we had that night. And from 8 o'clock to 10:15, it was a pretty innocuous event, really. You know, we had sporadic 50 to 65 mile an hour wind gusts, a few trees down, and there was one mesovortex that did form about 30 miles northwest of Sioux Falls, but something that was fairly easy for one radar operator to handle. They could handle the severe thunderstorm warning and then the one mesovortex they kind of kept an eye on to see if it would produce a tornado or not. Well, that changed at around 10:15, and in that time, we went from having 50 to 65 mile an hour winds to having widespread 70 to 100 mile an hour winds in Minnesota and Iowa, as well as 7 tornadoes, including 2 EF1s. And those tornadoes all occurred with 5 mesovortices in the span of 60 minutes. And so after the fact, we went back and looked at talked to the radar operator, myself and a lead forecaster, Jim Murray, talked to a radar operator and asked how it went and how we could improve. And the one thing that became very evident in our analysis is that the warning forecaster became overwhelmed by the multiple mesovortices because it changed so quickly. There wasn't time to bring someone else in to help them look at the radar and make warning decisions. And they felt that they were falling behind by trying to look at both the mesovortices and then the overall squall line. And so we came up and discussed a different way we could approach these type of situations. And as Kyle mentioned, the plan was to do it in 2020, but this situation came up 3 weeks later. So our plan was not really too different probably from what most of you do. We decided to have a warning coordinator. We would always have 2 warning forecasters if we expected QLCS tornadoes, and we'll talk about that more in a little bit. We'd have a mesoanalyst and a communicator. And so the middle 4 of these would be in the middle of our ops area, which is right over here. So the 2 warning forecasters would face each other. On this day actually ended up being on the standing desk, so they could literally see each other as well over the monitors. And so they could easily talk to each other about what they were seeing on radar. And the mesoanalyst and communications person were on the other sides of the square, if you want to call it that, and they could easily talk to either warning forecaster without having to shout or anything like that. So it made a very integrated warning forecast team in the middle of our ops. And then we had our warning coordinator sitting just off to the side where they could talk to all 4 people. And then our gridded forecaster, who was our 6th person, was actually off a little bit away from the operations, mainly because they needed to do the forecast since this was during the mid-shift and keep the grids up to date, but also so that we could keep our warning team all in one place. Now, in an ideal world, what we should have had is we probably should have even had another 1 or 2 people so that we could have had, instead of a mesoanalyst and social media person as one person, we could have split those 2 operations up. So we had 1 dedicated mesoanalyst and one dedicated social media person. So that's kind of a lesson we've learned from this event after the fact. And you could have also had another person for flash flooding, given there was heavy rain with these storms as they moved across the area. As I said, we're going to start talking about the two warning forecasters and how we want to approach these. So most of the time, well, all of the time before this case in Sioux Falls, we would split our warning forecast operations, if we did split it, by geography, like north of I-90 or south of I-90. But for this event, what we decided to do based on August 17th is we're going to split it up by the type of warning we're going to issue. So warning forecaster number 1 was responsible for all the severe thunderstorm warnings only along the line. So along this entire line, they looked and issued severe thunderstorm warnings. Warning forecaster number 2, they were focused on the mesovortices. Their job was to issue all the tornado warnings that were necessary for the event. And the advantage of this, we thought, is we now had 2 people looking at the entire line at all times, in addition to anyone else in the office. But 2 people were dedicated to looking at the line and making warning decisions, and they were talking about the evolution of the line as it went on. What our strategy was to go for longer and a little bit larger severe thunderstorm warnings, and then as needed, add TOR possible tags and also increase wind speeds as needed to 80 or even 90 miles an hour. And then, so those severe thunderstorm warnings would be on the order of 45 to 60 minutes. Then we would go for shorter and smaller tornado warnings from 30 to 45 minutes for the mesovortices, or the circulations that were found. And in the end, what we were striving for is to have an open discussion with all the staff, especially the warning operations people, on the evolution of the circulation, so that all warning decisions were made by a group of people. You know, not just one person, and usually not just 2 people. Usually 3 or 4 people would chime in. Sometimes it was pretty quick, as you'll see as Kyle kind of described. Some of those changes came really fast. But it was to make sure that we had informed and a consensus warning decision. And we also hoped that would decrease the likelihood of missing the circulation. So here's what the timeline looked like for the warnings from when that mesovortex, just before Kyle started looking at it at 11 o'clock, until it went through Sioux Falls. So the first warning, there were warnings out before this. So I'm starting kind of midway through. But at 10:47, we issued our first severe thunderstorm warning with 70-mile-an-hour winds. That included just the western portions of Sioux Falls and then counties to the west of there. And then at 10:53, we issued a tornado warning for one of the mesovortices, the northern one actually. There was already a tornado warning out for the southern one, and that included west of Sioux Falls. And at that, 2 minutes later, we added a TOR possible tag to the entire line as well, and up the winds to 80 miles an hour, so to get a little bit more enhanced wording with that. 7 minutes after that, we issued a new tornado warning that included the southern portions of Sioux Falls, you know, into Lincoln County. And at the time, as Kyle described, we were thinking the tornado track was going to take it primarily through this area, and then there was a second circulation down here that we were also a little bit worried about. But we thought it would stay south of Minnehaha County, or the city of Sioux Falls, I should mention, which is up here, and that's Minnehaha County, is where most of the city is. At 11:13, we issued a new severe thunderstorm warning that included Sioux Falls and put in 80 miles an hour and TOR possible into that warning as well. And then finally, at 11:27, as we realized that, you know, the new spin up to the north over the shopping district and the sharp turn, we issued a final tornado warning that included all of Sioux Falls. So over this time, we issued 5 warnings plus another 5 statements with that. In addition to that, we also were talking to our emergency management and partners. So in this time, we sent out 3 chats to the media and to emergency management on where the circulations were. And one of the things we were really trying to emphasize was beyond the tornadoes was the wind, because we were really worried that Sioux Falls was going to get hit by 80+ mile-an-hour winds, which we did, and that was going to cause a lot of damage, and that people may not take that threat as seriously as the tornado warnings. But we also tried to point out where those circulations were to help the media and others point out where the real threats were. And finally, we also provided 2 briefings to Minnehaha County Emergency Management between 11 and 11:25 as these storms were approaching as well, so that they were aware how things were changing as quickly as possible. So we were able to get a lot of information flow out to people, whether it was to the public, emergency management, et cetera, through warnings and through other communication means. So in summary, in 15 minutes, we really went from a situation that we thought we had pretty well under control, tornadic circulation moving south of Sioux Falls, with a squall line moving in with 80-mile-an-hour winds, and it changed on us in a matter of 15 minutes. Suddenly, the mesovortex changed direction at 11:22 p.m. We had two EF2 tornadoes actually at 11:25 p.m., one with the main mesovortex and the second with the smaller one that hit the hospital. And then we had rapid tornadogenesis over the south side of Sioux Falls between 11:25 and 11:27 p.m. And along with all of this came 80 to 100-mile-an-hour winds over the south and southeastern portion of the city that did building damage and tree damage as well. So a lot happened in 15 minutes time. And so what we found and what we believe is that by splitting the radar operations the way we did, it allowed us to react more quickly and to put more information out. As I said, we had two pairs of eyes dedicated to warning decision on the same geographic location, just making different decisions. And this allowed for constant discussion between the radar operators and others on warning threats and the evolution of the storms. And this information was then used to communicate the threats to the media and to the EMs through NWS chat or through phone calls. And what we really think is that although our last warning came out just as a tornado touched down on the south side of Sioux Falls, in all likelihood, if we had had only one radar operator, we probably would have been too late with that warning. We probably wouldn't have gone out till 11:29, 11:30, or 11:31. So by having two radar operators, we think we saved time, and we also were able to communicate the threat a lot better. Thank you very much, and we'll take any questions anyone has.
I'll go ahead and say thank you again to Phil and Kyle for this really interesting event, and thank you to everyone who participated asking questions and being on the line to hear the event. And thank you again, and we will see you all in a couple weeks.